Hello there. We have a question, basically testing or assessing our understanding of Newton's laws. So we have here a man stands in a lift that is accelerating vertically downwards as shown. So we've got a man inside a lift where the lift is basically accelerating downwards. Which statement describes the force exerted by the man on the floor? So basically, this requires some knowledge of Newton's third law, especially in determining which type of forces is acting on which type of body. So to approach this question, I would suggest first we consider a situation in which only the man is within the lift, in which the lift is not moving. So if we consider only the lift that is not moving, that means, and then we try to identify what are the forces acting. So we have, of course, the weight of the man, but the weight of the man is acting on the man, which is the weight of the man acting on the man by the earth. So this is gravity, or this is weight. And also we have the contact force. Let's just label this as N, where this is the contact force on the man by the lift. Okay, so these are the two forces that are basically acting on the man when the man is within the lift. So by considering only these two forces, since the lift is not moving, there's no resultant force. Based on Newton's first law, when there's no external net force, then the object will either remain at rest or in constant velocity because there's no acceleration. Therefore, if we assume, for example, all downwards forces is positive, then we can assume that the gravitational force due to gravity acting on the man will be equals to mg, positive mg, minus the contact force from the lift on the man, and this one will be equals to 0. Okay, so and then there's another force based on Newton's third law. Okay, based on Newton's third law, for this contact force, there will be an equal but opposite magnitude R that is acting on the lift by the man, which is actually different, where N is acting from the lift on the man. So the Newton's third law equivalent pair would be the same contact force from the man acting on the lift. So remember, for Newton's third law, there are basically 4 conditions in which we need to identify. Number 1, it must be equal in magnitude. Number 2, it must be in the opposite direction. Number 3, it must be the same type of force. So this is where most students actually get confused. You can't assume that the reaction pair of forces, if one is a contact force and the other one is gravity, they're not the same. Okay, you need to be able to distinguish it. And last but not least is that it must be acting on different bodies. So mg is equivalent to N, yes, but R is not directly equals to mg, because R essentially is equals to N in the case of Newton's third law. So it's quite a reach for us to get what is the R here, because when you talk about the statement of the force exerted by the man on the floor, we are not referring to N, but instead we are referring to R, which is the force acting by the man onto the floor of the lift. So based on Newton's third law, we've got R, where the magnitude of R will be equivalent to the magnitude of N, but the directions are different. Now, from here we know that N is equivalent to mg. So this is the first case when the lift is not moving. So now let's consider when the lift is moving downwards. So when the lift is moving downwards, or what we call accelerating, okay. So we've got the man here. So mg is still there because the man is not going out of space. It's not at the moon or at the different planet or whatsoever. And then we've got another n here, where n, let's just label this as n1. Okay, to differentiate with the n when it is not moving. So here would be n naught, and this will be n naught. So here, is this the only two forces that are acting? No. You've got the resultant force where it is basically accelerating ma, because it is moving downwards and it is accelerating. Assuming that all vectors that are acting downwards as positive, we can get the overall equation here. Positive mg minus n1 would now be equivalent to ma. So there are two different equations, equation 1 and equation 2 here. So if you compare n1 in this case, where this one is n0 and this one is n0, n1 will be equivalent to mg minus a. So compare between n0 and n1, you can get r. So basically this is r0 when r is not moving, or when the leaf is not moving. So there will be an equal but opposite direction acting on different bodies of r1 here. So r1 here, the magnitude of r1 will be equivalent to the magnitude of n1, where it is basically mg minus a. Because this is just mg and this one is mg minus a, therefore we know that r1 will be less than r0, where it will be less than the weight of the man. So if you want to feel good, feel good in the sense that you want to perceive as if you are losing weight, a good idea is for you to bring together your weighing scale inside a lift that is traveling downwards. Then you will observe that you are actually losing weight, so to speak, because the reaction forces of your weight onto the scale would be decreasing as the lift is accelerating downwards. Okay, thank you very much.